Starting a new chapter kind of today, a new lesson. We are moving on to chapter 12 and looking at lesson 6, so we're just kind of skipping around a little bit. And we're starting to get into statistics and probability, and more importantly, with this lesson, we're talking about whether or not we're counting things and arranging things in certain ways. And remember, at this point, you should have read the lesson. If not, please stop now, go back and read it, and then come back, and we'll kind of discuss this a little bit. But to do this lesson today, you need to know a few different things. And the first thing you really need to know is the idea of factorials. Okay, factorials are this idea that you are multiplying a number successively, right? So if you have like 5 factorial, right, that exclamation point means factorial. So 5 factorial just means, well, that's 5 times 4 times 3 times 2. And you can put the times 1, but remember, timesing by 1 doesn't change anything, so you really don't even need it. But you need to know that in order to do some of these problems today. So we're talking about counting and how we count things and whether or not order matters. And that's the whole key, is figuring out, hey, does the order of this situation matter? All right. So with a permutation, the order matters, right? You can't change. I mean, you can change the order, but it's a completely different outcome now. And that's kind of the idea, right? If you think of like winning at something, right? The order matters, right? Who got first is completely different than who got third, right? And I mean, those are two separate situations. Whereas a combination is saying, hey, the order doesn't matter. Where if you're picking something, right? Say you're picking pizza toppings, right? The order of the pizza toppings doesn't matter. If you get banana peppers, mushrooms, and onions, well, that's the same outcome as if you got onions, mushrooms, banana peppers, right? So I hope you see the difference between a permutation and a combination, right? Permutation, the order does matter. Whereas a combination, it's saying, hey, the order doesn't matter because it's the same outcome if you're using the same components. Okay? So with a permutation, you're going to need to use the formula that's given to you. If you know that the order matters, well, then you may need to use this formula, which is saying n factorial, which is the number of objects, that's what n is, and then divided by n minus r, so the number of objects minus the number of objects taken, right? And then that is also going to be factorial, right? So n is the total number of objects, whereas r is just the number of objects we're counting at a certain time, right? So that's the permutation. And for combination, it's going to look very similar. We still have that n factorial on top, still means the same thing. It's the total number of objects. And we still have this n minus r factorial, and r is still the same thing. It's just the number of objects we're counting at a certain point. But now we have a multiplication by another r factorial. All right, and I'll kind of show you some examples on how this is going to work. But those are the main formulas that we're going to need to know. Okay, so your assignment today was on page 790, and it is problems 11 through 31 odd. Remember, I'm giving you the odd problems so you can check your answers, not just write down the answers, but to check your answers to make sure you understand what's going on. And remember, you're going to have an Alex assignment tomorrow over this, so don't just write down the answers. Make sure you're doing the problems and then checking your answers. Okay? Excuse me. So I'm going to do a few examples. Number 11, we have a science fair, and there are 8 finalists in a science fair competition. How many ways can they stand on stage? So if we're talking about arranging a certain number of people, right? Obviously the order matters, but in this case we're not picking out of these 8, we're just arranging them. So we don't even have to use the formula here. We can just straight up say, hey, we are going to use 8 factorial, right? Because we're using all 8. So essentially, it's not going to matter anymore, okay? Because if you use the formula, that would be 8 factorial over 8 minus 8, and then that's going to be factorial. And it's going to get really confusing because you're going to have 0 factorial, but believe it or not, 0 factorial is 1. And I know that's confusing, so that's why I'm saying don't even worry about that. Just know that if you're not picking out of these 8, if you're using all 8 people, then just use 8 factorial. And which is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2. And if you multiply that all out, that will give you your answer. And you should get 40,320 for that one. So that's number 11. So I'm going to do a couple of the even problems as well. So I'll do one permutation example and one combination example. Okay, so like number 12. Let's do that one for instance. Let's just go ahead and do 12. So we have a permutation, and it says that we have a permutation with 6 outcomes, and we need to choose 6. Right? So six total, and we need to pick 6, I should say. Permutation, we are picking them. So 6 pick 6, and so n is going to be 6 factorial on top. And then my r is also 6, so that's just like the one we were talking about earlier, right? We're going to have 6 minus 6 factorial, but that's 6 factorial over 0 factorial. Now, I know that's confusing, but 0 factorial does equal 1, okay? And it's really abstract and kind of advanced math to think about how 0 factorial equals 1. All right, so I'm not really going to get into it because I don't want to confuse you too much. So then it's just going to be 6 factorial over 1, and if you do 6 factorial and you figure out that multiplication, that's just going to be 6 times 5 times 4 times 3 times 2. And you should get 720 for that one. All right. And I know you didn't have to do the even ones, but that's the idea behind it if the numbers are the same. Right? If the numbers aren't the same, they kind of work out a little bit differently. And so let's look at number 16. So number 16 is a combination, right? So remember, combination, the order doesn't matter, right? We're just choosing, we're choosing like a certain object, and it doesn't matter which order we pick it in. So we have 7 total choices, but we're going to choose 6 out of those 7, right? So if we're using the combination formula, our total choices, it goes on top, that's 7, so 7 factorial. And then we have 7 minus my total times I pick, so that's 6, so 7 minus 6 factorial, multiplied by our number of choices, or the number of times we pick those choices, so 6 factorial. Okay? So that's going to be 7 minus 6, which is just 1 factorial. And 1 factorial is also just 1, so I really don't even need that there, but I'm going to keep it there for now, times 6 factorial, and 7 factorial stays on top. Now, you can go through and you can multiply all of this out if you wanted to. And you could do 7 times 6 times 5 times 4 times 3 times 2, and then divide it by whatever 6 times 5 times 4 times 3 times 2 is, right? However, there's a nice easy step you can do here. Remember, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2. But 6 factorial is 6 times 5 times 4 times 3 times 2. Right? Remember, the 1 factorial can just go away. But does anybody see what you can do right here? Do you see how they kind of line up, right? So if you divide by the same number that you're multiplying by, remember, they just kind of cancel, right? So we can cancel all of these numbers out until we're just left with 7. So my answer for number 16 would be 7. And that's kind of how you can approach some of these problems, right? Um, and that's kind of the way that I like to do them. If you want to go ahead and multiply them out and then divide, that's fine, right? You can do it that way, okay? So that's 12 and 16. That's how you do the rest of those problems. 20 through 24, you don't have to do the math there. You're just trying to figure out, hey, does the order matter? If it does, it's going to be a permutation. If the order doesn't matter, it's a combination. You don't need to figure out what the actual number is, though. And so I was going to do one more. And let me just decide which one I want here. So I'll go ahead and do 25. So Abigail works at a jewelry store in the mall. Her manager asks her to place 3 of the 12 birthstone necklaces in front of the display case. How many ways can she arrange these necklaces in the display case? So we have to decide, hey, okay, does the order matter for these birthstone necklaces? Meaning, is it going to be the same if I switch around the order? And in fact, it kind of is. It does matter, right? The order does matter here. So I'm going to be using the permutation formula. All right. So my total number of objects here is 12, right? There are 12 total necklaces. So that's going to be 12 factorial on top. And then the number of, so the total number minus the total number of choices I have, which is 3, right? That's the number of choices I'm making, I should say. And then that's going to be over factorial. So I have 12 factorial over 12 minus 3, which is 9 factorial. So remember, you can go ahead and multiply this out and divide, but I like to do the easy method and cancel out where I can. So 12 times 11 times 10 times 9, dot, 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 over 9 times 8 times 7, dot, dot, dot. And if we notice, anything 9 or lower is going to cancel out. And I'm going to be left with 12 times 11 times 10 over 1, which is just 12 times 11 times 10, in which you get 1,320 different arrangements that she could make. Okay? I hope this was helpful, and remember, email me at any point if anything comes up and you're not sure how to do a question. Some of these are pretty tricky, and so I struggle sometimes trying to figure out, hey, does the order matter, for example? But if you email me, I will gladly write another video or find something to kind of help you with it. Don't think too much about how 0 factorial equals 1. All right, if you want to watch a video or something about it, you can, but it's kind of advanced and kind of confusing to think about, so I just wouldn't even worry about it too much. But remember, email me if you need help, and stay on top of things. You are doing a wonderful job with everything you're doing. People are asking me questions, and I truly appreciate it. And yeah, just keep up the good work. And if you need anything, just let me know. Thanks.